Hey, hi guys. Good morning.
Hi Shiva, good morning.
Yeah, good evening. So, yeah, how many of you guys have done the pizza project? I think I received only one from Mamta. I didn't review it completely, Mamta. Okay, I will go
Yes,
through it
sir.
completely.
Even I assumed all the inputs are correct, no, and like that, because I did not put in.
That's fine.
Shiva, one quick question, and the video with slides which you shared
Mhm.
regarding the last collections. I don't have it, and for the Maven, right? I wanted to try, but I don't have slides. And
You
if
don't
possible,
have
can
that.
you please share it?
Okay, let me see that. If you didn't find the Scala part 2 is not having that. If not, then I will give you the part 3. Okay. Yeah, I will share it with you. Okay. So I will put it in the drive. Yeah.
Okay, thank you, Shiva. Because Maven is something very new for me. I just wanted to know what it is.
Okay. Okay. So we were discussing some of the basic points about Spark last week. Like, so basics, installation setups, what are the services, the master and worker node history server, and these will be available only in sudo Spark standalone cluster, at least, or even if it is distributed standalone Spark cluster. So if it is not the case, then you will only find the Spark master running. But in your laptops, the latest VMs, as I was telling you, it's a local mode of installation where whenever you start your Spark shell or you run something on your Eclipse, so within one single JVM, all the services will be running. Okay. So that's why even if you try to open the master or worker or history servers on your web browsers on these port numbers, that may not work on your VMs. But yeah, but these are like, treat them as a info. In case, I mean, I don't think you will find a standalone Spark cluster installed anywhere in real time also. You will find this integrated with Yarn. Okay. I'm still again, I'm giving you, I'm trying to, yeah, let me write it down. Okay. So Yarn can be, Spark can be installed on either standalone or Yarn or Mesos, and the other way, so not a distributed one, and it is local mode. Okay, so local mode in one single JVM, all the services will be running. In sudo standalone mode, Sudo standalone mode. Also, each service will be running in a separate JVM, but on the same machine. In standalone, distributed standalone mode, so you will have it like you have all the each service running in a separate JVM and in a separate machine. So then that is distributed standalone. In my VM, so what I observe is like a sudo standalone mode of installation. Okay. And even in case if you want your master and worker services to be running on your laptops, I have given you the commands to run them start-master.sh and start-slave.sh. Okay. So I hope, so this much we have discussed, and we have started our shells with Spark Shell, Spark SQL, and PySpark, and we ran one example. So how to load a file into Spark Shell and view the contents of it on high level. Okay. So before going to the next items, so I want to take one simple example, simple Spark. Yeah, and one more thing is on high level we discussed like the project So on high level, the architecture is like, so if you take, just for example, so this is very high level I'm telling, there will be a client machine from where you will be submitting your Spark job. This I have already explained last week, but again revising because it has been so many days. And this needs the continuation for this week, that's why. Okay, so you will have a client machine where you will be submitting a Spark job. Okay, and that will get submitted to, first it will go to Spark master in case if it is standalone, okay, or yarn resource manager in case if it is yarn. Okay, so in our practice we'll see by default whenever you run in your Eclipse, that's a local mode of execution, and if you start your services also separately, and if you provide your Spark master address as the URL master URI, so that will become sudo distributed standalone mode. And we'll see, I will show you some examples on yarn also, but not at this moment. You will see in the cluster mode of applications running. Okay, so as of now we'll focus the basic building blocks. Okay, so client submits the Spark job, and Spark job will get submitted to either Spark master or resource manager, and these will, so once it goes to master, so then it will get distributed to your slaves which are called as workers in Spark architecture. And from workers, the results will be, so once the master allocates the workers, then this Spark job, so wherever the client machine, the Spark job is running, that is called as your Spark driver. So this is called as Spark driver. Once the master or resource manager allocates the worker machines, so then the communication happens between your Spark driver and workers directly. Okay, so your master or resource manager assists only till the communication happens between these two. So once this is happened, Here in Spark driver is like a coordination service, or you can treat this as like a master from there onwards. And inside worker machines, there will be an executor services. Inside that machine we call as worker node, but the service that it gets running inside it is executor service. Okay, so this Spark driver will give the tasks, will assign the tasks to these executor services. On these executor services, all those tasks will be running. Okay, so this is a very high level, or at least a bit of understandable level of recap of what we discussed last week. Okay, now, so let me get started with the development part of it. So in order to deal, or in order to submit any Spark job, when I call Spark job or Spark application, it's both the same. Okay, so they must have one driver program. So what is that driver program means? So whichever the main program, whichever the singleton object in which you have written the main def main method, so that itself is treated as your driver program. Same like we in our Mapreduce framework, we are calling that main method having all the configurations, right? So public static void main, inside the job instance creation and configuration setup. So in whichever program we were doing, we were calling that as a Mapreduce driver, correct? The same way here in Spark also, we have that driver program from which you call that main method. Inside that main method, you have all the configuration set up and Spark context object created. Okay, there is a lot more to discuss on Spark context in the coming slides. So driver program contains our applications function. Yes.
Hello.
Yes, ma'am.
Yeah, Shiva, I have a question. Before you proceed any further, I would request you to please provide some background on Spark, like why we need Spark. Up until few years back, big data was there, but Spark but not there.
Oh.
So what is that which is being replaced by Spark? Why it is so popular? So all this thing would provide some background. So if
I
you don't
think
mind,
we discussed them both in the demo and as well as the first session of Spark.
okay.
Okay. I mean, I don't have any issues in repeating, but if you are feeling like if I didn't give you that intro, yeah. So I gave that why we need to switch for Spark. So I spent only that purpose, only on that question. The entire demo goes on like.
Okay.
Okay.
Okay, then go ahead.
Yeah, to quickly recap for you. Yeah, that's okay, no problem. So to quickly recap for you, so whatever the tools that we have so far in Hadoop ecosystem that you see, the Hadoop ecosystem processing engines we have are MR and Hive. Hive is like a warehouse, okay? So anything that you submit either through Hive or Pig, they get submitted through Mapreduce, okay? And in case of Cloudera, in case of Hortonworks, there is a one more faster processing engine, which is a competitor for Mapreduce. Okay. And Impala at the same time has evolved from Cloudera to beat the performances of your Hive. So which is a one more layer, or which is competitor for Hive, but still uses the Hive Metastore and all those components. It cannot replace Hive, but this is one another processing engine that you can treat it like. And Spark. Okay. And there are few other frameworks that are coming, Apache Flink and few others, which are going to evolve in future. So they are going to run even more faster than Spark. But let's not consider all these things into scope for now. So what I am trying to give you heads up is that this is a continuous evolution. Okay. You should keep on adding the technical stack to your profile, your resume. The thing is, with Mapreduce or with Hive, with Pig, whatever you are doing, so it reads your input from HDFS and writes intermediate. So input is HDFS. Intermediate output is P output. Let me call this as partial output. So this will get stored in LFS, and final output onto. Final output is anyway fine from all the 4 types. We need the output to be stored on HDFS. Let's not worry about that. So the input gets read from the HDFS directly, and intermediate output also again from the disk. Okay. So when I give you the read operations from HDFS are always time taking. They take more time than reading from LFS. So do you agree on this? And anything
Yes.
reading from the local disk always takes higher time than reading from the RAM. Catchy. Okay. So this is the read performance phenomena. Now, so these two are like in Mapreduce or Hive, both input and intermediate output is being read from these two, HDFS and LFS. And in Tej, it also used a bit of same mappers and reducers kind of tasks. It used some bit better framework, but it was not that successful. So it was able to run only max of 4 times, max up to 4 times the speed of MR. Four times of MR. Okay. So it also reads the data, input data from HDFS and intermediate data from LFS, all those things. But it got evolved from Hortonworks Hadoop distribution. Later from Impala, so what it does is it will not use the Mapreduce. It will not. So since even though it looks like a Hive competitor, underlying Impala, it doesn't use Mapreduce. It uses the C++ MPP technique, massive parallel processing technique, where it stores that intermediate output in the RAM memory. Okay. So it stores only the intermediate output in the RAM memory. It still reads in the input data from HDFS. So since it stores the intermediate output in RAM memory, it runs faster. It runs very faster than your Mapreduce or Hive or these things. So how much faster I can say? At least you can see 30 times 2, 30 to 40 and sometimes 50 times. So based on your data and Parquet and all other real optimizations, all these things you do. Okay. And now if you take Spark, both reading, so input also gets loaded into RAM. Even the intermediate output also gets loaded into RAM. So both input and intermediate output, everything gets loaded into RAM memory, which runs always faster. And so that's the reason it can gain up to, so in theoretically you see up to 100 times faster than MR, but at least based on, it purely depends on the how much RAM memory that you have allocated. So it's vice versa. Like, so if you are allocating 100 GB RAM or for your yarn and only few less memory for Spark,
when you say RAM,
yeah, let me
when
complete.
you say,
Let me complete.
okay, sure.
Okay, let me complete. Okay, so here in the ideal configuration scenarios, you see that Spark runs up to 100 times faster than Mapreduce. This is purely because it reads everything into RAM memory, and from there it loads everything into RAM, and from there it processes the data. And anything reading from RAM is always faster. That's the reason why Spark runs faster. And when obviously if something running faster and it's giving you faster, quicker results, everyone will go for that only. And so unlike your Impala is not a open source, even though it's giving 30 to 50 times faster speed. It comes only with your Cloudera. You can't run it on all flavors of Hadoop distributions. But coming to Spark, same like your open source community tools, Spark can be installed either on existing Hadoop cluster or as a standalone Spark cluster. Just reading from a local file system is also possible, but which might not be the case in all the real-time projects. Real-time projects, you will see Spark setup on one of the existing Hadoop clusters and integrated with your yarn framework. And so in our demo itself, I have given you some performance metrics. When I ran a Mapreduce job, I think I remember Mapreduce job metrics. The word count Mapreduce program we have written around like 70 to 80 lines of code. Whereas in Spark, I have written that in 1 line of code. So this saves lots and lots of development effort, right? And it's so clean and concise. And this development cycle efforts are going to take more. Okay, so these are the two, like one is a performance. Second one is concise, clean and concise, and development cycle will be, development will be faster. And yeah, so if I tell the numbers there, like almost, so when the Mapreduce job was taking around 2 minutes or so, I still don't remember properly. It was just taking not more than 20 seconds or 10 seconds. And one thing I still remember is like, yeah, for Hive queries. So Hive, I have given you Mapreduce with Spark Native, Hive with Spark SQL also. So which was taking 95 seconds in 95 or 95 seconds in Hive, whereas in Spark Native or Spark SQL, it was just getting completed in 2 to 6 seconds. Okay. So these are the few points that why any enterprise project should think of if it is being developed on distributed framework, it should first consider the Spark as its choice. Now you go ahead with your questions, Mohan.
Yeah, so when you say RAM, so you mean to say that slave nodes RAM, right? Whatever slave
Yeah,
nodes we have.
let's discuss those internals now in the sessions. Okay.
Okay, sure. Okay.
So you don't worry about which RAM. That's a, of course, that
Okay.
answer is yes, but
Okay.
yeah, let's discuss that in the current sessions. So this is what I explained in the demo class.
Okay.
All the points. Maybe you might have missed that, the demo class.
Yeah. Sorry for dragging back.
Yeah. Okay. So anyone else having any questions on why we need to learn Spark still?
No, Shiva, if what is the approximate RAM which they use, and if they use, then the average RAM is will it
This
be?
is again a repeated question.
No. I know. I asked this question. No, what I mean to say that, see, for the existing Hadoop clusters, if they add more RAM, will it be faster like Spark? It may not be that faster, but what will be the difference? I just wanted to, I'm not asking about the Spark.
I didn't get your question at all.
For the existing Hadoop cluster, if they increase the RAM, sometimes increase the RAM, it will be faster. Will it be any better performance?
Obviously, whenever you increase the RAM memory, your existing Hadoop cluster will always run faster. But
yeah, and
at the same rate,
then why do we need Spark here?
Let me complete. That's why I'm don't stop. Okay. So at the same rate, if you increase the RAM to Spark, it runs again 100 times faster than your Hadoop. You're getting my question? My point? See, at any point of time, given the same resources, it can run up to 100 times faster. That doesn't mean that if you run this, see, if this guy is earning 50K and if this guy is earning 5 lakhs, if this guy gets promotion to 1 lakh, so does this guy stay there only? I mean, that's the scenario like here. So with the same configuration, the Spark runs even more faster if you allocate the same amount of RAM memory for Spark. Okay. So now, yeah, at least let me get started with the development of it. So in order to start building or developing any Spark application, the same way you are writing your Mapreduce driver program, we write a Spark driver program inside which we write our main method and we declare all our configurations and we create the Spark context object. Okay, there in Mapreduce. So I always compare this Spark framework native sessions, all these concepts, starting from the first session onwards, I will compare with the Mapreduce programming, because we are replacing almost the Mapreduce, and that is also a programming and processing framework, and this is also a programming based processing framework, right? So the same way you have seen Mapreduce driver programs, and inside which you have written main method and all declared the configurations, conf, all this stuff. configuration conf equal to new configuration, all that stuff, and set up your job name. Okay, so you are setting up the job name, job equal to job, new job dot name and main class, all that stuff, right? So now the same way in your Spark. So let's say if I'm going to write my word count example. So we have run that in the shell, but I want you to show the application first, so that I can give you basic roots to your Spark programs. Okay, so if I write an object, singleton object, so word count, so inside which I declare my main method def main string args, array of string type, whatever it is. Then same like configuration, new configuration that we have seen in Mapreduce. Here we have Spark conf object creation. Val conf equal to new Spark conf. And bare minimum be set in the configuration. What is the application name? Set app name. This is like your job name that we were setting up in the Mapreduce. Here, like word count. Okay, and if you want to set the master, if you don't set the master, by default it tries to connect to the local of star, so or whatever the master that is running on the local machine. Otherwise, in case of cluster, so these are the two minimum property parameters that we set in the configuration. Set master, so where your master is running. In case if it is sudo standalone cluster Spark colon your master machine host name, and generally it runs on 7077 TCP port number. That 18080 that you have seen, that is a web UI port number, whereas 7077, this is a TCP port number. I always keep telling our Hadoop candidates also that you always should make a difference, should note the difference between a TCP port number and web UI port number. And again, I don't need to repeat it again and again. TCP port numbers are to interact with that service programmatically, and web UI port numbers are only for accessing those services only through web browsers. Okay, the same way like 8020 for your name node, which is a TCP port number to interact with your HDFS file system. 50070 is the web UI port number. Okay, and 8032 is the TCP port number for resource manager, and 8088 is the web UI port number. Okay, I think one of our previous Hadoop batch candidate did very good job. I think she prepared one very good Excel sheet with all the port numbers and TCP port numbers, default numbers, all these things. Let me find that sheet and share it with you. Okay, yeah, let me come back to the original topic. Now, so the very first step we do is we prepare a conf object, Spark conf object, and the bare minimum two parameters we set. Application name, what is the Spark job name that you want to give it to it, and what is the master which you want to connect to it. If you have a sudo standalone cluster or a standalone Spark cluster, you can go give this, or the other options that we give are, for now, let's assume only local of star in your local mode. This is the master URI that we give. for now, consider only this thing. When we discuss the cluster applications of your Spark, then we can think of what needs to be given for yarn, what are the other possible values for local, what are the values for your Spark standalone cluster. Okay. So this means local of star means you are getting connected to your local master. So once you have the conf object created, so you have to create a same like there in Mapreduce, we were job new configuration. So if you still remember configuration new configuration. So this is what we were doing. So job equal to new job of or job.get instance of conf comma your job name that we were giving. But here we use val sc spark context, new spark context. So we pass this conf object. Okay. So this is one of the way to create the Spark context object. And once you get the Spark context object, so this is as good as like, so you got your Spark shell. So by default, whenever you open a Spark shell, it creates the conf and it creates the Spark context object for you. And it provides that Spark context object as SC variable on your shell. That from there onwards, you can load your any of the files. Let's say if you want to load any file, let's say val file equal to sc dot text file, that readme.md file that we have loaded in our last session, right? readme.md. So this one you loaded and just printed those file.first or file.count. These are the operations that we did in the shell. So the difference between your shell and your application that you write inside your Eclipse. So this is the things like you will write all this logic inside a singleton object and main method and create a conf and Spark context. These extra 4 lines you'll see, and anything else that you write here. So rest all of them you can directly first test and execute in Spark shell. If it is giving proper results, then you can put it into your program and then you can build it as a jar, and then jar can be submitted onto the cluster. Okay. Again, cluster means all the 4 different ways of cluster. Okay. So I will not be explaining all the parameters for the cluster submission, the job at this moment. When we discuss the cluster Spark applications in cluster mode, there you will get all those things. So my initial focus is to make you write at least a simple Spark application and then try to do with this. Okay. And coming to the building part, let's say this is my simple Spark project examples project. So in this I have same like any other in case if you want me to repeat this. So for your basic understanding. So new Scala project. Okay. Now, inside this, what I will do is, I will just take this word count not Scala, and it's a simple one only. So if you don't understand some of the statements or some of the lines of Spark code, for now it's fine. Create a Scala object. Okay, so here, so these two got highlighted as errors. These are not available. The reason is you can understand that the Apache object Apache is not a member of package R. That means it's missing the dependencies. So what we have to do is convert this. It is a simple Scala project. So you convert this into Maven. So this will help you again, once again, Mamta. So convert this into convert this into Maven, and you will get the default pom.xml file. And as I have given you already, so the bare minimum dependencies that you have to put for any Spark application. Or you can take the pom.xml file that I am sharing with you, at least for your Spark native, Spark SQL, and Spark streaming as well. Spark streaming and Kafka related things also. Let me close all these things. So in the pom.xml file, so just replace this. So here in the dependencies, if you observe here, so what all things that I have, Spark core is needed at this moment for you guys. Okay. So going forward, if we do the Spark SQL development also in the Eclipse, then we need Spark SQL. Spark SQL with Hive, we need this Hive dependency. So when we are doing Spark streaming, this is needed. And when we are doing Spark streaming along with the Kafka, we need these dependencies. So one thing that you can do is, I will anyway share the Spark projects as it is with you. The same thing that I used to do with each batch. I share in the example source code. So I share those entire projects as it is. Okay. So Eclipse project as it is, so that you will get everything. Okay. So here you can see in the pom.xml file, this was one of the projects that I shared. So once after all, you'll get all these examples also. I think in this only Spark core is there. Yeah, the latest ones might have that. Okay. So once you prepare the pom.xml file, so right click on the project. So Maven. So where is Maven? So Maven, update the project. And only our project, select update only our project. Don't do for all. So once you update the project, then all its So syntax errors will go away. So if you build it now, if you build it as a jar, so at max, if you see here, so in the main method, coming to the code, so I'm taking the input file from argument 0, output file path from argument 1. So creating the object of spark conf and setting the application name, and master by default it should connect to local. So I left that, created the spark context object and read that input file and did 2 lines of code. Okay, so for better understanding, I split this into 2 lines of code. So otherwise we could have it even done in the 1 line. Everything, all these 4 lines. So by default into your shell, you will get all these things already done, like so spark conf and spark context created, and your spark shell itself act as a driver for you. And for better understanding, I split that 1 line of code into these 4 lines of code here in this program. Okay. Now, so if I build this, so run as Maven build, so do a clean install of it. So clean install means it deletes anything that is already present in the target, and then it recompiles all the programs in your project and builds a jar after compiling all those. Okay, so for the initial build, it takes a while because it has to download things that it needs. Okay. Okay, so let that take some time. So let's resume back to stuff. Once it is successful. Okay. So, so in any driver program, the bare minimum things that are needed is, one is a spark conf object creation, and then the spark context object creation. And driver programs access Spark through a Spark context object, which represents a connection to a computing cluster. So via the Spark context object only, you will connect to your Spark. So in the shell itself is our driver, and Spark context is automatically created as SC. Then we can run various operations on this RDDs. So create RDDs and all those things. We can discuss more about all those RDDs later. And driver programs typically manage a number of nodes called executors. And once this driver connection, driver makes a request to master. See, once the client submits the job, whichever the client machine that is running gets connected to master, and master allocates some worker nodes. And inside the worker nodes, so there will be services called executor services running. So those executors will be under control of your Spark driver program, this Spark context. Okay. So the same steps here again I have written. So Spark conf, configuration for Spark applications. First step of any Spark driver application is to create a Spark context. And in order to create a context, we need Spark conf. The Spark conf stores configuration parameters that our Spark driver application will pass to Spark context. Same, if you understood your Mapreduce driver program, there we create a configuration conf, and after that we create a job object job equal to passing the conf object. Same. So two mandatory settings of any Spark application that we have that have to be defined before this application. Spark application could be run. Those are like, one is app name and the other one is master. And again, this master is becoming like optional now. If you don't specify the master, it gets connected to the master service running on the local one or the sudo one, local of star. Okay. And other than these two parameters, configurations, if you want to set any other parameters, we can use always dot set and give your property name, comma, its value. And for specifying any other properties, you can see this link. So you will find lots of Spark properties there. You can change for any of those properties values inside your Spark application. Okay, but again, anyway, we'll revisit these setting up of all these configurations at cluster level in the Spark clusters, Spark applications in cluster mode. There is one separate topic to discuss the cluster tuning for your Spark application. For now, so if you want to start your Spark shell, so you can directly start with Spark-shell. But if you want to see what are the configurations that Spark shell is using, you can start your Spark shell with --conf spark.log conf equal to true. If you set this as true, then any configurations that were set in the Spark, they will get displayed as the info messages. Okay, so finally this got built successfully. So then that means it creates a jar in the target folder. Creates the jar with target folder. So I always suggest you to use the jar with the dependencies always instead of the without dependencies jar. But anyway, let's come back to that later.
Shiva, why it is created with two jar files?
Okay, so one without adding the dependencies, and one with including the dependent jars also inside this same jar. Is that fair enough, or you want me to explain even more, like what is mean by dependency?
I mean, the dependency means we are adding in the pom.xml, right?
Correct. So when you are running, so the dependency means the pom.xml files, the artifacts that you add there, right?
Yeah.
So this is nothing but a one jar file, correct?
Yes.
So in sometimes when you are running in a distributed cluster, generally they should have the shared libraries where the Maven repositories, where the Maven repository should be there on your edge node, and they should have all the dependency jars available there. If it is not available, the dependent jars, sometimes it may fail. That's the reason why I recommend to use a jar with the dependencies also to be created. So for that, in your pom.xml file, we specify one property here that, so if you observe here, I have added one plugin to create a jar with dependencies. So this is the plugin that causes okay. So that causes to prepare a jar combining the other dependent jars also into this jar only. So which will be huge in size generally, but it will not have any dependency issues or exceptions, class not found exceptions. You will not face even in the cluster when you are running in a big clusters.
Okay.
Okay.
Thank you.
Yep. So, yeah. Let me get started with the Spark shell. So your Spark shell can be directly opened, that we have seen already. If you want to open with Spark dot log conf equal to, meaning log the configuration properties as info messages. Spark dot log conf equal to
Shiva, are we running the same program in the shell, or what are we doing here?
So here I'm not running that program in shell. Shell, I have shown you that WordCon program, I think in the demo session. I can run that, but I'm not doing that. What I'm trying to show you is first make you familiar with the Spark conf and Spark context object, and how we use that in writing a Spark application inside Eclipse. Okay, so inside Eclipse, in order to write even a very simple Spark application, so I'm creating the Spark conf object and creating the Spark conf and Spark context both, right? But in the shell, you already get those Spark context object created. But when you are within a shell, if you want to check your configurations, what are your configurations, then you can check. And few other points related to conf and context, I'm going to discuss. So here, execution is not my main focus. That is not my focus.
Thanks, Shiva.
Okay, I'm still continuing on few other points on the configuration and context objects.
Okay, thanks, Shiva.
Now, so when you are running with your shell, so in real time, when you're running it on your edge node, whenever you log in into your Spark shell, sometimes you don't know what are the parameters that your administrator has set up for you. So maybe if you want to check them, so there are various ways. So one out of them is from within your shell itself, you can check your properties. Okay, so starting from your Spark 2.0 session, 2.0 version, so it has set the logging level as 1. That's why, otherwise you should be able to see all the Spark configuration as the info messages. And whether you have an idea or not, so whenever the log4j properties work this order, right? So if the logging mechanism will have different levels. I hope you might be having this idea. Debug, info, warn, error, and final. Right? So if you set your logging level as debug, then all debug here, you should treat them as a level 0, level 1, level 2, level 3, and level 4. Okay, so if you set your logging level using your log4j, all our Hadoop ecosystem tools use log4j mechanism only. If you set any logging level, so you will get the log messages of that level and higher level. If I set my log level as debug or 0, I will see all debug messages, all info, all warn, all error, all factory. That means I see every log message. If I set info, then debug messages will never be displayed to me. Only info, warn, error, fatal. If I set as warn, only warn, error, and fatal, but not debug or info. That's why, so by default now, starting from Spark 2.0 version, so it has set that log level as 1. That's why in the latest releases, we are not getting those many info messages. Otherwise, our screens were getting flooded with all those information messages. So that's good for one thing, and this bad for this. So tracking this configuration through the info messages. But anyway, we can do with one more option is that you can create the Spark conf object here, val conf equal to, so from SC, from Spark context, again you can get the configuration object using the sc.getConf. Okay, so Spark context.getConf will give you the conf object. See, conf is now Spark conf object, right? On conf object, you can use either get all to get all the configurations. So if you observe here, so some of the Hive meta store warehouse directory is this, and Spark master is, by default, as I was telling you, local of star, and Spark home path is this, and Spark submit deploy mode is client. You might not understand all of these things at this moment, but at least, so this is how Spark application name is given as a Spark space shell for the shell, okay, and Spark.logconf property, this is just now I set it as true before entering into the shell, right? So that one, and where is your Spark driver is running on? So this is the host name, the IP address for that, okay? So these are the properties that were set up on my Spark conf. Or you want to get property by property also, you can get that. I think we use the, get option, the property name, it gives you that. That is also fine. Get conf dot get option of Spark dot local directory. So if you want to get a particular property, where is my Spark local directory, which is a scratch space. So as of now, there is nothing in this. Spark application name, Spark master. So you can try these things. Okay. And one more option is you can even print the toDebug string. toDebug string is, it has a different purpose. Everywhere debugging your Oddities or the objects, we'll discuss a bit more about during the debug. But for now, here the scope is like to get all the conf. You can even use this conf.toDebug string. It gives you all the configuration properties. I think this is more readable than the previous one. So this warehouse directory, application name, driver extra class path, driver host, driver port number, executor ID, Spark home, and other properties that you have seen. And anything that you want to set, you can always set through the set method.
Shiva, here we are always mentioning as local, right? Somewhere you mentioned when you are running the writing the code. But here in the specification, if go back to shell, shell. Yeah, here it is set spark.master is equal to local.star.
Local
so
of star. Not
So even though if we mention spark.master, it still takes local, right?
No, I didn't specify a Spark master.
No, you didn't specify. You specified local of star somewhere. I
Yep.
don't remember where.
Okay.
But here local.star is assigned to Spark Master. Even though if we give Spark Master in the code, it is going to run fine, right?
Yep.
So in the real-time scenario, are we going to use Spark.master?
Yes.
Okay. Okay.
Okay. Oh, I got your question. So this is a method available on like a set master. You're asking either set master. Yeah. Okay. So this is a method name available on Spark context. If you set this and if you take anything this way, this is one option. Or otherwise, what you can do is, if you know the method name properly, you can directly give the master as local of star. This is one option. But what if you want to set other property? Set local directory. So instead of giving a separate methods, then later what they realize, they have given a generic method where you can give the property comma value kind of. So here you can give the same thing. You can give this way also. Okay.
Okay, got it. Thank you.
Yep. So these are like either I'm about to explain them, or you are always ahead of me, right? I know that.
Sorry, my bad curiosity.
Okay. Yep.
Good and bad both.
Yeah, no problem. Okay. So which is, I was telling that, so same way, so the get is on the conf object, get is used to get the property. So the similar way, so here you have seen in the previous slide, either you use get option specify the property name, or just the get specify the property name. Get option is something that, so this is applicable for data type. Sometimes you see the get methods with their data types, both in Mapreduce, and the same convention is followed in Spark also. Mapreduce also on a conf object, if you want to get, we use get int or get double, get float, get boolean. You will have such methods based on the data type also. If you know the data type, you can give them. If you don't know, it's not a problem. You can still use the get. Okay, so only keep in mind at least the two methods: get, give the property name; set, property name comma value. If you know what is the method that is available specifically, then you can use set master or set app name. For this set app name also, we have like spark.app.name and give the word count here. So what I would recommend you to is, you don't need to remember these names. Set different names for different properties. Just remember only one set method for your properties. At least in that case, you have to remember the property names. Some are the other way. So for the list of properties that you can set or get, you refer this page. Okay. So what you can do is, I think I clicked on this. So these are all the properties. Okay. But at this moment, so since you are just starting with your Spark basic program, so you don't need to worry about all these properties for now. So when you're writing a program in cluster mode, And when we at least complete 3 or 4 sessions of Spark, then you go ahead and explore all these properties as much as possible. Okay, you don't need all these properties. Whatever you need, bare minimum, those properties I will try to cover in the sessions itself, in the slides itself, they will get covered. Same like your HDFS site.xml, HDFS default.xml, Mapred site.xml, Mapred default.xml, and Hive site, Hive default. So whatever the properties that you see there in the configuration files, so these are the properties, but by default, they will be available in the Spark default Spark defaults.conf file. They should be available on this. Okay, in the Spark configuration folder, in the installation folder, you see all the conf related properties. So where did we install our application? I think in OPT.
Shiva, so OPT is for it's an optional directory, right?
Optional.
So this is for specifically like apart from Hadoop, whatever we do, right?
Apart from, it is not like that. As a standard, like as a practice, you can set up any additional software that you want to install in this optional directory. Yeah,
what I mean to say that by default, whatever application comes, apart from that, whatever we install, correct. So that's the standard practice to go in an app directory, right?
Yes.
Okay. Is it the same
pattern? If you want to share your application across multiple users, then we install that in a user libs.
Okay. User lib.
Yep.
Okay. So in the real time, everything will be under user lib, right?
Few things, again, the same concept applies. So if anything that's specific to be user, it's the reverse. Okay. Yeah, it's the reverse. So anything that needs to be user specific needs to be installed in user lib folders, and anything that needs to be common across all the folders, you will put it into OPT, optional software, and given the access to it, so everyone will access. Of course, you can do the reverse vice versa also. It all controlled by the file permissions given by your administrator. But generally, the practice is like, if you install anything on user lib, generally each users will not have direct access to the user libs. The common softwares, they will install it on the OPT. But in real time, if you observe, you will find even in the real-time clusters, you'll find your OPT Cloudera common related stuff installed in the OPT Cloudera folders. But users, some of the packages parts here in the same your Quickstart VM, you will find 2 types of Clouderas installed on your Quickstart VM. One is through your Cloudera manager that gets installed through /opt/Cloudera folders, and SCM agent and SCM master. So, and the other one is through parcels that got installed through user lib. Okay, and don't go till that level. It keeps on confusing you, and it's purely for administrators. Unless until you are really need of this, I don't like explaining all this thing. These are purely for administrators.
Thank you, Shiva.
Okay, I think we are getting deviated so many times today. Yeah. So these are the various ways that you can refer your configurations, that you can check your configuration. Go to your conf folder, sparkdefaults.conf, or if you want to provide any configurations by logging into your shell, You can give hyphen hyphen C, hyphen hyphen con, or just one hyphen C. Okay. And so what the other thing, through applications using the Spark conf object creation is specified. Okay. So that's all about the Spark conf object. And then coming to the Spark context. So we create Spark context object. So by taking the conf object. So and this is the most widely used or the popular way of creation of Spark context. We have other ways also. We have 3 more ways also, but we rarely use them. Okay. So Spark context internally offers these many functionalities for us. So it maintains RDD graphs, DAG scheduler, task scheduler, scheduler backend, listener bus, block manager. So at this moment, I'm not going to discuss all these things. Meaning sometime you will get it. Okay. So these are some of the operations that offers the Spark context to us. So with Spark context object, we can read in the Spark conf. Just now we have seen sc.getConf. It returned the Spark conf object. And we were able, with the help of that, we were able to see the master URL. We were able to see the application name. We were able to see the deploy mode as client there. But I didn't explain what is deploy mode, what is its values. We'll see later. What are the default level of parallelism? Who is the Spark user, version, all these things. Okay. And we can set the configurations. These are like getting configurations. And we can also set the configurations, master URLs, any properties and locking levels, all those things. And we can create Oddities. We can create some other advanced concepts in the objects in the Spark, which are like broadcast variable accumulators. We'll see more about these things. But on high level, what are the operations that it offers for us? You can read the configurations, you can set the configurations, you can create objects, and you can access services like the ones that I have shown in the previous slide: task scheduler, block manager, and scheduler backends, shuffle manager. Okay, so you will get to know all these things slowly, one by one. For now, at least catch these terminology. Okay, and it is responsible for running your jobs. Okay, and closure cleaning and setting up scheduler backend, task scheduler, DAG scheduler, submitting jobs asynchronously, and persisting, unpersisting RDDs. So we didn't talk about all these actions, but for now, just take them as index. We'll discuss them one by one. You will get them one by one. Okay. So for getting the Spark context object, either you can create new Spark context of con, or if there is an already existing context, you can get or create. So either this option is also possible, but the most widely popular one is this way of creation of your Spark context. And these are the other ways. Okay, just give me a 1 minute break. I'm back. Okay. So, yeah. So why I left this page, it's for your reading. Okay. So these are the other ways of creating your Spark context object also. Like without providing any conf object as parameter, you can create that. And with providing the Spark conf object, so this is the most popular one and most we use. And okay, and you can directly provide your master URL and application name, and then followed by the conf. Okay, or if you can even call this way master name, application name, and your Spark home directory, and any jars, any dependency jars, the sequence, a list of strings. Okay, so a list of strings, comma separated strings. Okay, environment properties, it's a map of all those things. But this is like a I never used, at least. Okay, so the more frequently used, and you see lots of examples with this thing only, even in Drupal and wherever. So you create your Spark conf object, and you can do this also. So why I am giving you all these things, sometimes when you are referring, so even if you find your Spark context objects getting created other ways, you should not get surprised. Okay. Okay, and similarly, the way we create Spark context, when we go to Spark SQL, there we see again two types of context. One is a SQL context, and other one is a Hive context. Okay, Hive context has more functionality than the SQL context. It is a superset of the SQL context. And Spark community suggests its developers to use Hive context over SQL context. But anyway, so this is just a info, one-liner info. Okay, at this moment, we'll discuss more about that. So I'm just preparing you that similar to Spark context, you will see SQL context and you will see Hive context, and streaming context also, Spark streaming context also you will see. So for each of these tools, you will have a separate context objects. Okay, and if you want to create a SQL context, we pass the Spark context object as the parameter. Same way, if we want to create the streaming context object, again we pass the Spark context object as the SC as the parameter for that to create it. So again, the chain of actions, conf, Spark context, and then SQL context. And to create Hive context, we make use of this SQL. And similarly, for Spark streaming, we use con, Spark context, and then streaming context. Okay. So the very basic core program that we have seen there. So loading a file into your shell and printing the first line or the line count. Okay. So the next, this Python example, Java example. I'm not much interested in this Python or Java examples. But Scala example you have seen, and these are the slides that how to build your application. I think this one I have already shown you in the Scala part of it itself, and I covered that today again. So whatever the jar that I have built there, if you want to run that, so you can use this syntax, spark-submit, but running is not my focus now. So I want you to make comfortable with the programs first. So you are now, at least I'm hoping that you are now comfortable with the two lines, the first two lines. Spark conf object creation and Spark context object creation, and setting up some configurations if needed, and getting them if needed, whenever needed. Okay, and yeah, so that's it. So on Spark context, once you get the Spark context, so what all things that you can do? Setting configuration, getting configuration, and creating objects. Setting configuration, getting configurations, we have seen, right? So these things we know with get method, and this is for set method. Now let's see the remaining services. You will get to know, I mean, it may not be in the same sequence, but you will get to know all other things that we can do with the Spark context. So the next topic is Oddities. Yeah, before we go to the much complex programming, first we understand what is RDD. So RDD is nothing but a collection of data. Definition wise, I can give you so many terminologies, but in layman terms, if I have to tell you, you can treat this as a file.
As a
File.
okay.
Okay. Any file that you load, that is an RDD. Okay. So definition wise, I can give you many things like it's a collection of data, resilient distributed data sets, or a data set. Again, I will explain you all these keywords anyway, but you can treat this as a file. Okay. And yeah, so coming to its terminologies, RDD, it's an acronym, stands for Resilient Distributed Datasets. So the first word, resilient, means so fault tolerant. Fault tolerant. If the data is lost, we can recreate them. Okay. And distributed means this will not same like your HDFS mechanism. This gets distributed across the cluster, not maintained in one machine. The data will get stored across the cluster. And dataset means a file, right? So it's a group of data or a collection of data, which will come from a file or a streaming data or from any other source. The source can be anything. It's a group of data. And this is the unit of data, the lowest unit of data that we consider. And so this high level, what is meant by resilient distributed datasets. And some of the features of RDDs, these are very, very, very important. I want everyone to understand each line of them. So RDD's nature. RDD's nature you can't understand. It keeps on confusing you how to use them. Okay. So pay attention. Let me complete all the RDD's points and then I will give you some time. Okay. So don't stop me in the middle. Let me complete for at least till partitions, then I will pass for your questions. Okay.
Shiva, can I ask a quick question on resilient? I mean, I didn't get clearly what resilient means.
Fault tolerant.
So that means if some calculation on some node fails, then it will recalculate, something like that.
For now, fault tolerance means if something is lost, recover it. How How, you don't worry. I
Okay.
didn't explain that.
Okay.
Ask me
Okay.
questions only on what I explained. I mean, that
Sure.
doesn't mean that I'm not forcing you to ask me that. So what I'm trying to say is, I'm going to discuss more things. I just gave you the definition. Once
Okay.
after that, I can open some time for your question. Okay.
Sure.
Yep.
Sure. Thank you.
Yeah. So here, resilient means fault tolerant. If something data is lost, we recover it. Okay. How? Let's not worry now. Distributed means if you load a file, so same like your HDFS, it will not get stored in one machine. It will get distributed into multiple machines. And again, one more confusion people will get, that they will always compare Spark with your HDFS. First of all, I did that mistake. I am giving you the distributed nature. You should not compare your Spark with HDFS. When I say HDFS, literally HDFS. You should always compare your Spark with your Mapreduce. But when it comes to RDD, this is a file that is loaded into Spark, and this gets distributed in the Spark framework. But where was the original file was? It's in HDFS only. And people ask me that, what is the replication factor for your RDDs? Okay, if the source file is present in your HDFS itself, do you need replication for RDD? I will leave that question. I will not answer yes or no. If needed, yes, where we will provide. If not needed, let's leave that. Okay, so I'm opening a can of questions for you guys only. I'm putting them aside. I'm expecting that these might be your questions. Okay, but yeah, let me park them aside for some time. Wait for the answers. Okay, that will not stop, or yeah, that's not a hard stop for your next understandings. So resilient is somewhat okay, like recovering your last data. Distributed means spreading your data whenever you load a file. So instead of loading that file into one machine, that file will get distributed into multiple work nodes. Okay, dataset is nothing but a collection of data. In the next points, RDDs are immutable. So we know this keyword very, very clearly. Immutable means we cannot change that. Once an RDD is created, we cannot change its value. We can't update that RDD. And we can create another RDD from this RDD by applying some transformation. You have an RDD R1. If you want to change some values inside that R1, you can't change inside that, but you apply your transformations. Apply, I want every value to be doubled. Okay, then do R1 into 2 equal to R2. So R1 remain as it is. Your R2 will get created with the double the values of your R1. Your R1 is not changed now. R1 still remains the same even after the operation that you did. So that means, so RDDs are immutable. That doesn't mean that you can't use them for any changes. So you can use them, but you can't change the existing RDD. You can apply your transformation, create a new RDD. Again, I'm not confident on this statement, how much you got it, but still okay. And the next point is they are generic. RDDs are generic. They can store any type of data. Okay, so these statements are like a contradictory, conflicting. RDDs are immutable. Again, I'm telling that you can apply transformations and you can create new RDD. I'm not sure how many people you understood perfectly that statement. And the next statement is also like that only. They are generic and they can store any type of data. And again, in the next slide, I will say RDDs are fixed. Once you assign a data type, you can't change that. Okay, you have to carefully capture these statements. They are generic means an RDD can store any type of data. It can store RDDs of ints, RDDs of char, RDDs of boolean, RDDs of this. If you load a file, you can treat that RDD as a collection of a string. So layman terms, I told you treat it as a file. As a programmer point of view, treat it as a collection. File is nothing but a collection of strings. Don't you agree? Yes, you agree that. So file is nothing but a collection of string. I say it's a list of string, an array list of string. Okay, so if I go to the programmer level, so you can consider it as a collection of any data type. And your collections are generic, right? You can create an array list of int, array list of string, array list of double, anything. But once you create, you can't change that. Into an array list of string, you can't assign a number. Into an array list of int, you can't assign a string. Okay? So that is what this statement goes. Okay. And each RDD is split into multiple partitions. Same like your blocks. The blocks concept that you have seen in HDFS. If you upload a file into HDFS, that will get broken into blocks, and blocks will get distributed across the slave machines. Same here. So when you load a file into Spark, the file, the RDD will get split into multiple partitions, and those partitions will get distributed across multiple worker machines. So you understood how a distributed nature is achieved. Okay. RDDs can contain any type of meaning. It could be Python, Java, or Scala objects. Any type of object, including user-defined classes. This is a supporting point for this slide. Okay, let me continue. So we can use Spark context to create RDDs that we have already seen in our previous slides. When an RDD is created, it belongs to and it is completely owned by that Spark context only. Okay? And if you create another Spark context object in some other program, you can't send this RDD as a parameter to that Spark context. Meaning RDDs can't be shared between Spark context. RDDs cannot be shared between Spark context. That scope is, as long as your Spark context is live, your RDD will be active. So if you take this Spark context as the scope, so any RDDs you can create within the scope of it. Once you close this Spark context, all oddities will be lost. And this is a single oddity of strings. Like this is an oddity of strings. This is one string, this is another string, this is another string, this is another string. This is you can also treat this as a list of strings. And a list, if it is a map, another collection type, you can take this as RDD of pairs. Key value pairs, if you have, you can create RDDs of pairs also. Okay. I'm expecting still it might be vague, very vague for you. Let me spend one more slide and make you better understanding. So you have your data. Obviously, your Spark is not a replacement for your HDFS. It's a replacement for your Mapreduce. And then, if that is the case, and when you install your Spark on Hadoop cluster, and when you want to operate on top of the HDFS files, first you load the HDFS file into your Spark context that we have seen. sc.text file readme. It loaded that. Yeah, let me create file sc.text file. So it will create, it's creating an RDD, creating an RDD of string. So each line is treated as one continuous string, and that way it became a collection of strings, an RDD of strings. Okay, for now at least don't worry about the right side part of it. Different types of RDDs, I will again explain, spend one more slide for that. Now, so this file, a readme.md file, it's present in HDFS. That file I loaded. Hadoop fs-cat readme.md. Okay, so these are the contents of that readme.md file. So these got loaded. Okay, so these got loaded. I want to filter lines only that contains Spark keyword. Okay, val filtered equal to file dot filter. Same, I told you, right? I told you to consider an RDD as a collection, and I have given you some functions on collections that are most popular. I told you the names to remember all of them, right? Filter dot file dot filter for every line. This is my anonymous function. Line dot contains. So on string, I have a contains. So whenever this returns true, only those lines will be. Okay. Now, filtered dot count. How many lines are there with the Spark? So result is long, 11 lines are there. Or if I want to have filtered dot collect, it displays me all the lines that has the Spark keyword in this. Okay. So here in this, so whatever this filter, I loaded this file, readme.md file. I loaded. This is a file. When I loaded through the text file, it returned me an RDD. So now file is an RDD type. And when I applied a transformation, this is a transformation. When I applied a transformation, I got another RDD. Okay. And I did some action on this. I got some result. Okay. But anyway, transformations and actions, let's pass them for some time. Now, so what happened is it loaded that HDFS file into Spark. If you remember your big functionality, same way on your left side, we keep on giving the aliases and loading a file from your HDFS into pig and storing those results back into your HDFS. Correct? So here also, similar to that, you're loading a file from HDFS into Spark. When I say Spark, it's into RDDs. And now in pig, it was storing in some pig temporary workspaces on HDFS or on its local directories, on pig's local directories. But here in Spark, it will not store. Yeah, it will use as the temporary work storages and temporary directories, all those things. But its final goal is to store into RDD. And where does RDD get stored? And how does it get stored? Let's say the same like when you push a file from your local to HDFS, that gets divided into blocks. Now when you push a file from HDFS, to Spark, it has to store somewhere. Let's discuss that where that somewhere is in few minutes. Before that, it divides that file into partitions. But in simple terms, if I have to tell you, so it treats those files, file blocks as partitions. By default, if you upload a 1 GB file, I'm not sure how many of you concentrating. So if you upload a 1 GB file from LFS to 1 GB file from LFS to HDFS, you will get 8 blocks, right? And if you load the same file into Spark, RDD, then it gets them into 8 partitions. The same file you can correlate with RDD, and the block you can correlate with partitions. Here, this was getting stored. Underlying behind the scenes, the 8 blocks will be stored in the local disk of your 8 different data nodes. LFS of or hard disk of your 8 different data nodes. Here, instead of local disk, it gets loaded into RAM memory. RAM memory of what? Your executor service. Executor is nothing but a JVM service, I was telling you. Same, all the services, name node or your data node or your master or whatever it is. All these services are your Java services only, right? JVM services, JVMs with some RAM amount and some CPU cores, right? Some RAM amount, some RAM memory, some CPU cores. That way, each executor on the worker machines. Let's say they have 10 GB RAM. 10 GB RAM allocated only to your Spark executor service. And that way, you assume on 8 different data nodes, you have 8 executors. Same like your data node services, you will have your executors JVMs also running. Now, this RDD, when you load this into Spark from this HDFS file, so it identifies that the file is having 8 blocks, so it will maintain 8 partitions, and it loads those 8 partitions into the RAM memory of the executor services. Let's say out of this 8 GB, so it will allocate that 128 MB for just for this one partition of this RDD. I know this is more of like a technical and more of like a architecture. Distributed frameworks are always like a, unless until you pay very close attention, they might be like a gray area. So 8 partitions now means 8 partitions, each partition with 128 MB size, are loaded into the JVMs of your executor services. Inside that, the RAM memory. So inside the executor services, there is a component called block manager, or the block, like a block coordinator or block something. Block manager is available with the Spark context, and here block driver or something is there. Okay, block storage or something. So this is responsible for storing this partition into the RAM memory of your executor. And from your Spark context, it's the block manager. Block manager is responsible from your Spark context, from your driver program. So here in this case, your Spark shell itself is your driver. When you are running it in a shell, your Spark driver is, your Spark shell is your driver. And in this Spark context object, it will have the block manager, and it provides the instructions to this block storers on the executors. Hey, slave, store this block or store this partition into your RAM memory. Now this, so the driver is instructing all the executor services, 8 different worker nodes, 8 different executor services, loading that 128 MB partitions into their RAM memory. Okay, so it may get extended the session for another 15 minutes or so. I don't want to stop in the middle of this. I'm trying to go as slow as possible to explain these things. Okay, just a quick update on the timing. Okay, so data inside RDD is stored in memory as much size as your executors can store and as long as possible. Now, so that is how your memory, your data gets loaded into RAM memory. Okay, so I am hoping that how does your local file from LFS to HDFS, and from there to Spark, and Spark to executors, and within that Spark from driver to executors, and executors JVM's RAM memory, it will get loaded. So now finally the RDD's data is present in our RAM memory. So I'm hoping that it is clear for everyone. Let me move on to the next point. It's immutable, read-only. It does not change once created and can only be transformed using transformations to new RDDs. Same like your pig. If you remember pig operations, pig transformations, pig is like a ETL kind of tool, right? Used to apply transformations. Either you want to do group bys, whether you want to do some filtering, whether you want to do filter the columns, whether you want to filter the rows, anything is fine. But the result of it needs to be assigned to a new bag or a new alias. Here also, same thing. Once an RDD is created, this file RDD is always fixed. You cannot change. You can't do anything to change the file contents. Whenever I say file.collect, it always gives the same value. You cannot change this result, the result of file.collect. If you want to change anything, you can apply some transformations, that's it. Or wherever you see Spark, replace that Spark with Hadoop. You want to do that transformation, you do it. But the result, capture that result into one another separate output RDD. This is input RDD and this is output RDD. So that way, so file is immutable now. You can't change the file contents with any operations. Okay, and there is nothing more to explain on that point. Next, lazy evaluated. Yeah, so the data inside RDD is not available or transformed until an action is executed that triggers the execution. Now, so whatever this entire flow that I have explained here, so loading a data from LFS to HDFS, I mean, take this out, okay? It will not happen every time, okay? So consider your data is present in HDFS. So when you say readme at .md, sorry, I opened something else. So sc.text file of readme.md. So this time, the entire file contents will not get loaded into RDD. It just creates a variable RDD with strings. Here, when you apply filter transformation, then also it created another RDD variable. But when I applied the count, then the block reader occurred, the short circuit local reads feature cannot be used this anyway, okay. So whenever you apply an action on this, until then, all these statements will not get executed. Same like your pig. Same like your pig shell or pig engine. In pig, until your pig script encounters a dump command or store command, it will not execute the previous statement, right? The same here, your action, until you encounter any action that needs a result. See here, count means I'm expecting the count. Give me what is the count. Collect means collect all the values and display me. And similarly, there are various types of actions and various types of transformations. These are the two types of operations that we can do on RDDs. So whenever you do any transformations on the RDDs, your actual data will not get loaded into your RAMs, or actual operations will not happen. Only when you run an action, then only all the previous dependent operations will get executed that moment. So when I run only on the .count, filtered .count, then the data from readme.md gets loaded into file, and from file, the filtering will happen into filtered, and then it gives the count. Until then, these are just variables, same like your pig aliases. This is nothing but lazy evaluation. Only when you need a result to be printed, result to be captured, result to be used, only when a result is expected, that time only the execution will happen. I hope that is also clear. Cacheable. So this is again a confusing point. Confusing. Already your RDD data is present in memory. In memory means RAM memory. RAM memory means cache memory. Then what else is cacheable means? Yep. So in order to explain this, so let me take again this example. Here, so what will happen in this case, when I run filter.count, it will go to a readme.md file, get loaded into file, and from file, filtered will get created into so when I run this filter.count, so the readme.md, this file RDD gets created, and from that RDD, filtered RDD gets created, gets calculated, okay? And from that RDD, the count will be applied. Now, after the action is performed, all these are released. All these are freed out from your RAM memory. And then, again, when you run this filter.collect, so again it starts from beginning. It loads this readme.md into file, and from that file gets loaded, it prepares this filter, and from that filter, it prints the values. This is something that you guys might not be able to accept it in the first go, either accept or digest. So for every action that you do, how many number of transformations you do, it will not execute. But if you perform an action, for every action, it starts from the beginning. If you apply count action, it starts from file RDD will get created first, and filtered RDD will get created next, and then the values will come into this, and values will come into this. Until then, these are just like a variables, a plain variables, just for fun. And if you perform another action, collect on this, again file will happen, file will get created, and filter will get created. So if that is the case, so which you might not be able to digest it, but what we can do to overcome this is, so if you feel like why this is built such a way that you will be creating lots and lots of RDDs, and if you keep all those RDDs into RAM memory itself until you explicitly release them from your RAM memory, you might not do an efficient job in releasing them. Then you will end up with only handling small files. Even with small files, if you create multiple RDDs, if all those RDDs once calculated and stored in RAM memory, with just 100 MB itself, you will eat up, if you do 110 transformations, you will eat up 1 GB of your RAM memory. And RAM memory is relatively smaller in size and very costlier and very faster, of course. So that reason, once an action is performed, once you get the result, it assumes that you no longer need those RDDs, the dependent RDDs. It frees that space. So in case if there is an RDD that is going to be used again and again in multiple actions, you can cache that results, meaning you can persist them on RAM itself. Store these values until I tell you to remove them. Otherwise, it will remove. So if you want filter to be stay there in the RAM memory itself until you tell explicitly, it will get stored in the RAM memory. So for that, simple thing is filtered dot cache. It got cache. So the results of this, after a first action is performed on this, the results of this filtered will get stored in the RAM memory until I unpersist them. We also call this as a persist or cache. Persist means store them in RAM memory, but you can do various places a persisting of your RAM RDD contents. So if you cache them, so they will get stored in the RAM memory. Now, if you perform any number of actions, it will not start from the beginning, but it will take the filtered results directly from your RAM. So that is what this caching means. RDDs are cacheable. So either on your RAM memory, which is the most preferred option, okay, if not on your local disk also, which is a very least preferred one due to access speed. And the next one, parallel. So since you have partitions and each partition is present in a separate executor's RAM memory, and that executor can parallelly run its task on that partition. And in the previous slide, I have told you that RDDs can accept any data type. But here I am telling RDDs are typed, means fixed typed. They can accept, still both the statements are true. RDDs can accept any data type, but once you set the data type, you have to insert those data type values only into that. You can create an RDD with long RDD, with string RDD, with map RDD, with anything. But once you declare it, meaning statically typed, once you declare it, you can do. Same like your collections. You can create array lists for any data type. But once you create an array list for one data type, into that list, you can add elements with that data type only. And partition, by now, I think you already got it. The data inside RDD is partition, split into partition, and then distributed across nodes in a cluster. One partition per JVM that may or may not correspond to a single node or a single executor. Don't worry about this line. So one partition per the executor, the JVM running for the executor services. And this is the way, these are the three different ways you can create an RDD. Either you pass a collection as a parameter, sc.parallelize, provide any collection. It could be a list, it could be a sequence, it could be anything. It could be a map also, okay? Pass a collection and create an RDD. This is one way. And the more common way and the most used way is that loading files into Spark context. sc.text file, load the files. So it creates RDDs. And if you want to make an RDD just with some numbers and some values or something that you provide, the third option is that sc.make RDD 0 to 1000. This is also nothing but a list of 0 to a list of integers 0 to 1000. So these are the three different ways of creation of oddities. Okay, and these partitions, so as I was telling you, so by default one partition is created for each HDFS block while reading HDFS files into Spark Oddities. Okay, and if I go even more inner details, even more in depth, you should not consider a block, but you should consider as an input split. In terms of Mapreduce terminologies, we have an input split corresponding to a block, HDFS block, right? The difference between input split and HDFS block is that your HDFS blocks may get broken at the middle of the line, whereas your input split reads till the end of that line, even if it is beyond that size, to have that one complete line into the input split, the same nature. Okay, so each of these partitions, default size of 64 MB or 128 MB, will be stored in RAM memory of executors. And every RDD has a fixed number of partitions that determine the degree of parallelism. Let's say if you have 1 GB file that you loaded, that will have 8 blocks, means 8 partitions, means 8 parallel tasks can run. So the number of partitions will determine the degree of parallelism that can happen. Okay, and Spark will always try to infer a sensible default value for partition. By default, it will apply. Yeah, by default, it applies based on the block size. Okay, so you can check in your Spark shells, you can check with this sc.default parallelism. So how many parallel tasks that you can run at the same time. And if you want to tune the parallelism, we can do that. We'll discuss that later. But for today, so what I want you to, at least what I thought I should explain to you is mainly the Oddities features. We are not yet into the actual programming. So we just saw, first we understood the first 2 lines, Spark con, Spark context. Now with the Spark context, I'm able to create an RDD. Okay, and able to understand these RDD features. It gets stored into in-memory, it is immutable, it is lazy evaluated, and RDD's results can be cacheable, and obviously they are partitioned and they are parallel processing tasks. And they have data types. They can accept any data type. Once declared with the one data type, it can accept only that data type values. Now, your turn for questions. I'm expecting at least 5-6 questions.
It was overwhelming, Shiva.
Means you didn't understand anything, or?
No. I could understanding something was out of my flow. So, one quick question I had, like, see, whatever the recently you told me, and something is there. That's it. You said that difference between whatever the block size we have, that will get loaded into RDD.
Mm-hmm.
That will be like a partition.
Yep.
And it doesn't get split if the line is too big.
Yep.
If it is more than 128 GB, MB or whatever it is, more than the block size,
yep.
How does it accommodate?
Yep. That is like a input. See, so for simple terms, I gave you like one block equal to one partition. But ideally speaking, one partition equal to one input split. in your Mapreduce terminology, what is the difference between input split and block? There also, I give the same formula, the number of blocks equal to number of input splits. But the size may not be same. The difference is, let's say, if the first block, the last line, is not able to fit in within that 128 MB size. Okay? In your HDFS physical blocks, it may get split into two files, two blocks. But at the time of reading in a Mapreduce framework, the input split, it reads that remaining half of that record also into the partition, into the input split.
Okay.
Okay. Let's say if this is your one block, okay, and this is your another block, but there are some lines that ending here and ending here, ending here, ending here, and there is one line that is ending here and the next line is ending here. So this line number 1, 2, 3, 4, 5, 6. The sixth line is spanning across two blocks. Okay? But when you talk in terms of HDFS blocks, it exactly breaks in the middle of the record, no matter whether it's the middle of record or end of record, it doesn't care. But at the time of processing, if you read only half of the record, it can't take decision on this record because employee name might be present this side and department might be present this side. So to avoid such scenarios, till end of this line, it is considered as one input split. Even though block is here only, till here only, your input split till this line. Overall, the number of blocks equal to number of input splits, right? So here you have two blocks, here you will have two input splits. But the boundaries, the line boundaries or record boundaries, till the end of record, till the end of line is considered always in input split, and which is not guaranteed in blocks. So if you have to compare that with the partitions, you have to treat more in terms of a partition. You should think in terms of an input split.
Okay.
Okay.
Okay. Okay. Okay.
So, but why I take those blocks terminology is you are more familiar with blocks. People sometimes don't understand or don't remember what is input split, and they forget what is the difference between input split and block.
Okay. Okay.
Okay.
And, okay. I had another. Can you please go back to those slides if you don't mind?
Yep.
When you say in memory, like whatever, like input split, that like from the HDFS, it will get loaded into memory, right?
Yes.
So since you're saying it is like a cache, that's why it is immutable feature ways.
Not since like cache.
No, not the
By
cache.
design itself, they didn't enable the mutability on them.
Okay, okay, okay.
Why?
And
I didn't explain. And to be frank, I don't know. Okay.
okay. See, I think because you are loading in memory, right? If the data changes more, and again you have to load again and again, right? So it's better instead of that. Like anyway, you're saying it is a lazy evaluated.
Yep.
The old one will get deleted, and the new one will be evaluated, right?
Yep.
It's as good as the new one, right?
Yep.
Because you are deleting the old one, and you will have the new one, and when you transform or when you assign new thing, whatever it is.
Correct. Whenever you execute it, it freshly gets loaded once again. And that,
Yeah, because the design itself like that.
yep, yep.
And one thing is caching, I did not understand. So why do we until you said that something you showed, until you get explicitly mentioned, it will.
See, it stores into RAM memory, but if you are running multiple actions, let's say when I running count, that's why I clearly told you that you again gets confused here. If you run this action, so it will start from beginning.
Yeah, I
File
understood
will
that.
get loaded, filter will get loaded, and then count will be calculated. And then again, if you perform the next action, so it will not take the result from this filter. It will start from the beginning.
Yeah, I agree.
You agree that, right? So if you don't want that to happen, so you already calculated filtered. Okay. And you have the count result. That means for getting the count result, you have to calculate the filter. And on the same RDD, I'm performing one more action. If I start from the beginning once again, it is a like extra headache, right? Extra time that I'm spending.
Okay.
So if you want to stop that, you can cache. This will persist in RAM memory until you tell that to remove it.
So okay. So there will be a way to remove this.
We'll discuss that later.
Okay. I'm not asking.
See, I'm not focused here.
I'm not asking that. Okay. So I just wanted to. Okay, I got this. On the same object, whatever we got it, and the same thing we ought to do another operation. So we don't want that to read from the beginning, right?
From the beginning. Yep.
Okay. So when you say parallel, it's the same like the
partitions.
Yeah. Got it. So because you are loading into different this one. Okay. And one more question I had. And can you go to the next slide? Okay. Here you said RDDs are once you create that type, you cannot create it, or you cannot load the other type. I just have I'm a bit confused here, because when we say
when
I create an RDD,
if I have val lines equal to sc.text file, this one, and lines equal to, you can't assign another RDD which is of different data type.
Okay. But these lines can have any data type, right?
It is at the time of loading, it's decided it's RDD of string. That's it.
Okay, let's say that I get the data from the database as a CSV file. I load that CSV file. So it will consider the whole file as string.
You are more thinking like column wise.
No, not a column wise. I'm just getting an example. Like, this is more easier to understand. I brought this.
Okay.
So in turn, you will have many other data types within that, right?
Yeah.
So I'm trying to get, like, if it is only one type, we cannot always deal with one type.
No, don't go till that level. We'll see that use cases. For now, what I'm telling is, make it simple. Don't go till that level where you have in one Excel sheet with multiple data types. Don't take that example for now. For now, take only Excel sheet with all the column names with string data type. Okay.
Got it.
You will get that use cases.
Okay. This one I got it. It's more like a pig, like you only when you say dump this one. Okay. And another, I think one more slide I had something.
I think someone got dropped off.
Spark will always try to infer a sensible default. I did not get that.
So it is nothing but based on the number of partitions, the number of tasks will get triggered. So default value for partitions is nothing but default block size.
Okay. Okay. Okay.
You're trying to question me on each and every keyword here.
No, not the keyword which I did not understand, because
Okay.
this is the only time, and tomorrow when I go to office and come back, I forget everything.
Okay.
Okay, I got
Yeah,
it.
let me give
Thank
chance
you,
to
Shiva.
others also. Yeah. Let me give chance to others also. Okay. Yes, Mohit. Seems like you had some questions.
I had questions, Shiva, but I will hold it for tomorrow. I'm getting late right now.
Okay. If they are quick enough, I can complete. Okay, but yeah, anyway, that's either is fine. Anything is fine. Kalpana?
Okay.
Yeah, Shiva, can you go to the Spark Shell example which we executed now?
Okay. Yep.
Yeah, you told like the once the action is performed, and again if you want to perform action, then it starts executing from the start. Here
Yep.
my question is like we have we have called the action collect on the filtered RDD.
Correct.
Why it is performing again on the file RDD also?
Yep. The reason is the filtered RDD results are not there. Okay. So once the filtered.count is performed, so when you are expecting filtered.count, you are expecting data into filtered. So in order to get data into filtered, from where it gets the filtered? From file. From file, it gets from the this statement.
Okay.
This statement is dependent on this, and this is dependent on this. Same like your big data flow language. So here, the dependencies. This is called as RDD lineage, which we will discuss tomorrow.
Okay.
Okay?
Okay, Shiva.
Yeah.
Thank you.
Thank you. Any other questions?
Shiva,
Yes.
okay, we have created an RDD. Since it is immutable, okay, I have got another RDD by extracting some of the data.
Correct.
Okay, then for the first RDD will the data exist or not? Okay, will it maintain in memory or not?
No, data will not be maintained for any of these RDDs. Only during the execution they will get loaded, and after the execution they will be flushed out. This is what I was telling.
Yeah.
Will be
If
there.
any action.
Yep. At every action, they will get loaded, and after the action's result is calculated, again they will be flushed out.
Okay, I have done an action on the second RDD.
Yep.
Okay, during that time, okay, first I have created an first RDD, and second I have created the second RDD,
Yep.
and I have done an action.
Yep.
Before that action task performed, okay, my first RDD will be maintained in a memory or not? Will be during the second time RDD that will be flushed out.
Okay, so your question is that when you are performing this filter.count, your data gets loaded into this RDD, and from that RDD, this RDD, from that this RDD. Okay, so now at this point of time, while it is running, anyway you need data into filter, but what is the need for data in work file? That is what your question, right?
Yeah, will that maintain in the memory or not?
Will that be maintained in memory or not? It's a tricky question.
Can you please come again?
See, his question is that at the time of execution, see, for example, so if I want to get the count of filter, so whenever I run this action, so at that time this file gets loaded, right? Data into file gets loaded, and then filtered gets loaded, and from filtered it prepares the count. Okay. Now, while performing this fraction of seconds, will this file will be present or not? That is what his question. There will be a fraction of seconds or maybe multiple seconds, but during that time will this file will be available in RAM or not? So what I can say is it may not be there. It need not be present.
Because it's the way they process, right?
Yep. So it need not be present, and I'm hoping that it might not be there. And there is no way that you can check that. We can validate that statement. You got something diplomatic answer, Gopi?
Okay, that's fine. Yeah.
I think from the design point of view, it is like how internally they process it.
I mean, it is not getting stored for a long period. Only during the action it gets loaded, and immediately after the action it gets deleted, flushed out. So even in that, you asked a very valid question. While executing action on this, we don't need to store this. Yeah, even if we store it will be for a few seconds. My guess is that it may not need to store that, and it might not store also. Once after the filtered is completed, unless until in its RDD lineage it finds any actions on file, it might not store that.
Shiva, like it's like more like a reference, right? See, you're just creating it. And when you say count only, it is going to utilize that, but that object need not to be there.
Which object?
See, it is when you say file, it is just a reference that will not be there, really.
Mm-hmm.
The way, I mean...
File will get really loaded into RAM memory.
Oh, you mean to say that it will get loaded?
Yep, the readme.md contents will really get loaded into RAM memory.
But it says that until you say count, it will not be, it will be a variable, right?
Until count only. Then during count only, I'm telling.
Yeah. So in that case, that file is just a reference point or like a variable or to load. But when you say count is the real operation, right?
Yeah, that is what he asked, Mamta. I think you didn't get his question clearly. He is not worried about the previous operations.
Mm-hmm.
You didn't get the question properly. During the count operation only,
mm-hmm.
when you trigger the count operation, it loads data into file, and
mm-hmm.
the file filter will get loaded.
Mm-hmm.
Correct?
Yeah.
So once the data get loaded into filtered, by the time it calculates count, let it take like a half a second or something. During half second, will file contents be present or not? That is what is question.
I think it's more for the usage, those things. Internally, I'm not sure. I'm just guessing.
Don't worry about all those things. I gave some diplomatic answer to him that, yeah. So it might not need to be stored. Let's not worry about that level of internals.
Internally, the Java, I know the Java JVM, in which language they have written, or what is the internal part of it?
Java, Scala. I was telling you again, like...
No. I'm not talking about the real JVM I'm talking about.
Mm-hmm.
Okay, I'll just find out those. Okay, this, I think, according to me, it may not be there. Only the count object will be there. That's just a reference point.
Okay. Any other question?
When they load like that, it is just a reference point, any files or something.
Shiva, another point. Okay, if I write these 3 statements in a function,
mm-hmm.
Okay, var file and then val file and val filtered, then filtered count.
Mm-hmm.
Then again I can write a statement like file dot count.
Mm-hmm.
Okay, then I think that data will persist, and even the scope of that particular variable will be available within the function.
Yep.
Yeah, then in that case, this file, the first RDD might be exist within the scope of that function.
Mm-hmm. See, RDD's scope within the functions, treat them like any other variables declared in your Scala program. The scope of variables within the function or outside of the function, it remains the same. Scope related to functions will not change. Same like any regular variables that you declare in your Scala program. Is that clear?
Yeah, Shiva, I got it. Yeah.
Shiva, can we combine two RDDs? No.
Combine. Well, you can union them and create one another RDD.
Yeah, because when I have two different results, if I have to manipulate combining those, I can do that, right?
Yep.
Okay, thank you.
Shiva, if we combine two RDDs, we will get another new RDD, am I right?
Obviously.
Okay. During that time, the two union data, okay, will that refer to first RDD? My concern is here, okay, what is the memory space occupied for this third union RDD?
Obviously, the combination of both.
Okay, like, okay, it will create a new RDD and that will create the space.
Yep.
Yeah, got it. Yeah, fine, Shiva. Thank you.
Yeah, I think you had some question, Kalpana.
No, Shiva, I'm fine.
Oh, okay. Purushottam. Yeah, sorry. Hey, sorry, Purushottam. I think you called me sometime on. I was not able to call you that day. Yeah, let me.
Today maybe I will call you.
Okay. Anything specific? Anything urgent or anything? Setup issues or something?
Yeah, setup issues something.
Okay, I think we have set up that Spark. This Scala ID, all those things on your machine. Is it quick setup?
Yeah, that is fixed.
Okay. Yeah.
Shiva, one more thing. We created an RDD, right? While file is equal to x.text file or something. So how can we identify this is RDD or just normally created a variable, right? How can we?
So how can you identify that is if you have a file. So if you just type file, so that gives you that it's an RDD. Okay. So if you are within a shell, you can identify by this way. And if you are within a project, you can obviously identify that by the return type of this, right? So what does it returns? See, the text file is returning RDD. Or if you go here, if you highlight on Eclipse, you can identify this as RDD.
And one more thing. So if RDD is nothing but one file is nothing but an RDD, right?
Yep, file gets loaded into RDD.
Yeah, you said before that you can create number of RDDs, right? Means it will be very lengthy, right? Means one RDD means one file can have a large amount of data also. So,
Correct.
So it will be parallelism. RDD Spark also it will be processing as a parallel, right?
Correct.
We created 10 or 20 RDDs. Is it processing parallel?
Yep. All those will be having partitions and all those will get executed parallel.
Okay. And Spark, you said this is by default, it is a partition. Means externally we no need to do any partition or what?
We don't need to do partitions. Spark will do a default partitions for us. And if you need to do custom partitioning, we'll see that tomorrow. Okay, the next immediate slide is how to do custom partitions. In case if you are not satisfied with whatever Spark did for you, if you want to shuffle the records and if you want to repartition them, you can do all those things. We'll discuss.
So I think partition is we can specify, right? I want to do partition on the following the columns and all. But
that partitioning, you are getting confused with partitioning in Hive.
Yeah.
And see here, partitioning in Mapreduce is different. Partitioning in Hive is different. Partitioning in Spark is more related to partitioning in your Mapreduce. Not even, yeah. I mean, more. I can. Okay. At least, yeah. It's more closer to the partitioning in Mapreduce. There we use hash partitioner to distribute your keys across multiple reducers, right? We'll see that. How does a partitioning will happen? Let's discuss tomorrow. On what basis and how to do custom partitioning? Let's discuss that tomorrow.
Let's do one more thing. In HDFS, you can store large amount of data, right?
Correct.
In RAM, are you able to store same data like in HDFS? Nothing, it can be storage purpose, right?
Yep. HDFS is for storage purpose. Spark is for processing purpose. When whatever the time that you are processing, let's say if you are processing your file, 1 GB file, 10 GB file, 20 GB file, or 100 GB file, you are processing that. You'll be processing that file for a 2 minutes or 3 minutes or max 5-10 minutes period. So till that time only, you'll be storing that into RAM memory. Why do you not need to store it permanently in RAM memory, right?
So I mean, all data is not required to store in RAM memory. Whatever the required data only you can store in RAM, right?
Yep. Whatever the file that you are going to execute currently, that will get loaded into RAM. And immediately after execution, that will be flushed out.
Okay.
Right?
Thank you.
Yep. And any other questions? At least I am happy after a long time that you all guys are speaking now. Okay, at least asking questions.
Because the actual subject got started, right?
Actual subject got started. Okay.
Yeah.
Okay. Okay. Thank you. Thank you very much. I think I'm taking a very long time today. From you.
Shiva, this week we have class.
We have one class. I'm requesting you guys to have one extra class on my Saturday evening 7 p.m. and your Saturday morning 9:30 a.m. EST. If you are Central, 8:30 a.m. CST. Central time.
Okay.
Okay?
Yeah.
Yep.
Shiva.
Yep. Yes, Purushottam.
VMware Workstation 11 you provided, full Workstation 11 version.
Correct.
Yeah, that is not supported my machine. So
yeah, because I saw a couple of issues with your machine. One is older Java version that I have seen or a higher Java version. And second thing is your machine is a 32-bit machine.
Yeah, that is the problem.
We all run all these high-end applications only on 64-bit machine support.
So what to do? I need to change that?
No. You download the VMware Workstation suitable for 32-bit machine, and inside that VMware, you will have 64-bit machine.
Okay.
Okay? You are virtually achieving that 64-bit machine. Okay?
Okay.
Yep. That is.
I have already VMware 10, I think version 10. Is it fine?
If that is working fine, no issues at all.
Okay.
That is fine. VMware version is anything is fine. I'm very least bothered about VMware version. As long as it is working fine, and that's I'm okay.
Okay. Thank you.
Okay. Yep.
Thank you.
Okay. Thank you, guys. Thank you very much for your patience and extending your time. Mohit, we can discuss your questions tomorrow as you are wishing. Okay.
Sure, Shiva.
Yep. Okay. Thank you. Bye bye.